Okay, so since Shuki joined Paul's group and learned coding from Mario, I guess he couldn't stop working on coding, and he kept getting his students to work on it also. So we have another panel on coding. So Andrew here is the moderator, and we swapped Bella with Li Hao. Li Hao will be here with Robert, Matisco, and Yao and Gad also. So it's a second coding panel.
After we keep you in yours, and Li Hao will be last.
Yeah, Li Hao can be last. Sounds good.
Okay, welcome to Flash Memory panel. So our first speaker is Rob Matescu, and we'll have everybody first do a little self-introduction, then present your talk. Thank you.
4 or 5 minutes is okay.
Yeah.
Okay. Good afternoon again. I'm Robert Matescu. I was a postdoc in Shuki's lab for 2 years, from 2007 to 2009. It's a privilege to be here again. And it was a privilege to be in Shuki's group at the time. And let me just try to remember a few things. There is a lot to say, but I am trying to condense a few thoughts and a few memories in a couple of slides. So I'm glad that today we talked again about embracing ignorance, because I became a student of that approach. I loved it. With the idea that you discover what you don't know, and it's an opportunity to learn. For me, it was not exactly the same time to have such an awakening. I'm also a Go player. I come from Romania originally. I was a good player there, and I went to Japan to study in a professional setting. And from being a young and strong Go player in Romania at around 19 years of age, I went to Japan, and I was actually an old and weak player over there, surrounded by 13, 14-year-old children that prepare to become professionals. So coming to Caltech, some memories from the past came to me. I was prepared. I was thinking, what am I going to do? I was done with a PhD in UC Irvine with Rina Dechter, as was mentioned today. And Shuki, through actually Rina's connection, was so gracious to invite me to give a talk in his group to see about possibly joining. And I remember that day very well. When he generously told me on the spot that he would like me to come, I had no idea what we could do together. He mentioned different things, probably just to put me, make me a little bit easy. And he mentioned maybe we can work on associative memories. And I thought, that's interesting. I learned something about that in my undergrad in Romania, something about Hopfield networks, who knows. I was a guy coming from graphical models and inference by search, by message passing, but I said, yeah, we'll try something new. It turns out that we discovered half of Shuki's prediction was correct. We worked on memories, but not the associative kind. We worked on something related to flash memory. So my first observation was that Shuki is at least 50% right. Actually, I would round it up. I'm a mathematician, so I learned to round it up. He's usually always right. So flash memory, I had no idea what that was. Seriously, coming here, I knew that maybe it's in our cell phone or maybe in a memory stick. I had no idea how it worked. But if I am to remember anything from my stay at Caltech, it's first of all our work on rank modulation. So the summer I joined, other people were in the lab, and I kind of heard Shuki was walking by. He proposed an interesting problem, which was combinatorial in nature. If you have a graph of permutations, can you find a cycle that goes through all of them with a certain kind of transition? And I felt like, okay, I don't know how this relates to Flash, really. But I can think of that graph problem, and I actually had some tools for constraint satisfaction problems, and I tried to encode it in a certain way. There is a huge step there, like when you take permutations of 3, it's very easy to solve it. You can do it by hand. When you take permutations of 4, the space blows up and it's incredibly big and it's hard to even make sense of it. But by looking at some kind of particular case, we were able to see something interesting in the number of cycles that are present, and we were able to actually give a general construction, which is mentioned. It's a small part of that rank modulation paper. And since we mentioned, it's the one on the left shown there. Since we mentioned numbering systems, I think we called it a B-factoradic or something. It's a factoradic number system that is present there, and all kinds of interesting things. And I was so happy in the following years to see that in ISIT and maybe other conferences, there was a lot of interest in this kind of setup, and many papers followed and tried to actually uncover a lot more of the beauty of these systems. But this is something that I enjoyed with Shuki, that when you talk to him, you know, often he would make a small remark or propose a simple problem, and maybe you don't think much about it on the spot, or feels like, yeah, it's a question, but in a couple of weeks or a few months, that thought becomes the foundation of your paper or your thesis or your imposter syndrome. So I had enjoyed lots and lots of talks with Shuki, every week at least once, I remember. We continued with some other problems related to Flash. One of them is in the middle there, wear leveling, another combinatorial type of ideas, which helped me to learn a little bit more about coding that I didn't know much about. And there is a little bit of element of network coding there that we looked at, and combining information. And I'd like to mention one more result that is after I left the lab, and it's kind of in the descendants of the work of Shuki. When Eyal visited our research group in HGST at the time, Western Digital, where I'm a researcher, we created this butterfly code. There was a lot of work in Shuki's lab on zigzag codes with Jing and I believe others. And these regenerating codes where you want to optimize the transfer, the amount of information that you transfer between nodes when you need to regenerate something that is lost. What is interesting about the butterfly construction is, again, it can be done with very simple operations, just XOR. So I have to say that I was obsessed with the even-odd paper. I'm glad it was presented again today. I actually studied it. I didn't know about it until I joined the lab, and the first few months I looked at it, and at the time I think I understood it completely. Right now I have a general idea. It's not very fresh, but I think it had a big influence in this type of work that we did on the butterfly code, just maintaining simple computations if possible. And there are other things and other ideas that we had at the time, but let me conclude that and say that the biggest joy was actually the people that I met. Amazing people in the lab, and through the extension of the lab from other places, it feels that the papers that we wrote are kind of secondary even. It's just an effect of being in the same room with these wonderful people. And I want to say that I am extremely grateful, Shuki, for having had you as a mentor. And I am even more grateful to continue to have you as a role model. Thank you very much.
Thank you, Robert. Our next speaker is Eyal.
Thank you, Andrew. Hi, so I'm Eyal Engad, and I was a student of Shuki since 2009 to 2015. And I had a lot of very great time when I was in Caltech with Shuki, and I remember very fondly the weekly meetings, and that often when I come, I was kind of a lot of times stressed. Sometimes I wasn't sure if I made good progress or something, and always Shuki first made me feel good and relaxed, and then we could go to the whiteboard and solve problems. So that was very good. One thing I remembered now today is I was TA in IST4, and I remember one time after the class, a student was asking a question to Shuki, and we were talking, and there was a discussion the discussion was about whether computers will be able to understand jokes or to tell jokes. And maybe after 10 years, it was, last few years, suddenly was solved. So I was remembering it, and I wonder if Shuki remember it and what he thinks about it.
At that time, I didn't believe it can tell jokes. I think we will need to improve our jokes in order to stay ahead. So, yeah. Anat, my wife, and I lived in Avery, and we had discussions about jokes because obviously at that time many of the Caltech undergrads didn't know how to tell a joke. And I was planning to have a workshop about telling jokes. I think now they can learn via ChatGPT how to tell jokes, but I think it's still, I would say, B-level.
Okay. Yeah. Okay. So I work in a company called Micron Technology in Flash. I was working with Shuki on Flash on coding for Flash, some rank modulation and extending it from permutation to multi-set permutations and other related application to rewriting codes in combining them with other codes like LDPC codes and Polar codes and others. And in recent years, I was working on this kind of LDPC codes for Flash. I was trying to see if we can put some rewriting or this kind of ideas in practice. It doesn't happen yet. Okay, and I made one slide about something recent that I saw in industry, in Flash storage industry, some optimization of the systems to artificial intelligence. So this is about workloads of AI that are dominant from GPU. And we try to optimize our storage system to the new workloads that are dominant. So one initiative is typically our storage have access unit of 4 kilobytes, and the AI application likes actually smaller units. They want a lot of input-output per second, but with smaller access. But we also need to still support what most of the other applications are using, which is a bigger access block size. So we are trying to make systems that support both of them, and it has some implication to coding, that we want the coding system to support both of them. So this is something we look at now in industry and how it affects also ECC system. So I just wanted to mention it. And that's it. Yeah. Thank you. Thank you, Shuki.
Thank you, Eyal. So both Robert and Eyal are actually also very modest people. So it's interesting that I know AI is very hot these days, and you can hear that Eyal is working on AI now, related to AI. And Robert used to be a European champion in the game Go, but he came to US and started studying AI. So I have a question for Robert. So do you regret the decision of giving up being a Go professional and came to study AI instead? Have you heard of a game called, a program called AlphaGo?
Is this working or? Not working? Is it okay?
Start talking.
Okay. Is it working? Is that okay? Yes. All right. Yeah. Thanks for the question. I don't regret the decision at all, but I actually continue to have an interest in Go. So I continue, maybe along multiple paths. Of course, I don't play professionally. I followed what happened with AlphaGo, since you brought it up. It's the moment in 2016 when DeepMind and Google built this machine and computer program and a lot of hardware that actually surpassed the best humans in the world. And this is a completely different approach than what happened in chess a long time ago with Deep Blue. And for me personally, it was the moment when it was a huge transition for me because I didn't really see it happening. I didn't really believe it was possible so soon. And now when I see the discussion, for example, with LLMs, that are they smart or not, and I don't know. I'm not sure if they will. I mean, I know a lot about them, but I don't know if they will surpass human intelligence. But I recognize a lot of the patterns that I've seen in the Go community before AlphaGo, like a year before or so. People didn't really think it will get there, but it got there. So let's see, there is a lot of excitement, and I think there are good things to come out of it. We shouldn't be afraid. Go continues, people continue to play Go, and they get better with AlphaGo and similar programs, and it's just a richer kind of life. So I don't regret
Okay, great.
studying like that.
Great. I think you made the right choice. Okay. So I'll be next speaker, and after me will be Li Hao. So we agree that we'll all do a little self-introduction, and this is mine. So my hometown is somewhere in this area in China. So it's a place with some nice lakes, rivers, and also gardens. And then I went to do my bachelor degree in the city in the north, where nearby there's a Great Wall. And after a few years, I came to here, Caltech, and had some of the best years I ever enjoyed in my life. So then after graduation, I went to Texas and started doing research. Yes, and so sometimes I wonder, why do I go to Texas? So what made it happen? So I was wondering until one day I saw this picture, and so you see, I went all the way around the world. And when I saw this picture, so this picture was Shuki 5 years old with his brother, and I believe in 1961. Yeah, so then you see the hats, the clothes. So, and I understood why. Okay, so maybe I was realizing one of the childhood dreams that Shuki had. Okay, so that was, the picture was taken in 1961, Shuki 5 years old. And quite a few years later, 38 years later, I came to Caltech. And so if you will look back, many things happened that we take for granted right now, but many technologies, developments have been happening. I remember that in 1999, the year I came to Caltech, that was the year I got my first email account. And also, that was the year I learned from a lab mate, why don't you try to use Google, okay, if you want to find something. So, and then in the year 2004, sorry, the number 4 is missing here. So in the year 2004, I got my PhD degree here, and that was the year when flash memory became popular as an accessory, not the main storage device, but as an accessory device. So, and it's that year, 2004, I got my first digital camera, and I was having a lot of fun with it. And that time, we had these flash cards, which had like 32 megabytes, 64 megabytes. So 128 megabytes was already considered pretty big. And it was amazing. So suddenly, we don't have to use the traditional films anymore, but rather we can store many images in the computer. And then 3 years later, in the year 2007, so you see the next picture, that's a picture of the very nice place in France called Nice. Okay, so we had a conference called ISTI over there. So a year before that, Shuki and I started working on this topic called coding for flash memories. And it's in 2007 that we started publishing papers on this topic. And I think we had a lot of fun. We just published quite a few papers on this topic for quite a few years afterwards. And so I remember that it was quite exciting. I remember that one day Vincent Bohosian, somewhere in the audience, Vincent told me that Andrew, so you are the student of Shuki who had the most papers with Shuki right now, because Vincent used to be the had the most. He was counting, and then I have the most. So I was a little embarrassed, but also very happy. And so we started doing a lot of research on this topic, and at the same time, Shuki also took another path. He co-founded a company called Extreme.io, and that company was acquired by EMC in the year 2012. And that was actually the leading all-flash enterprise storage system in the world. So I think since then, flash memory was no longer just a small accessory memory that you have in your camera or your phone, but rather it's actually now for main storage. It's replacing hard drives and replacing the traditional devices called storage. Now storage is actually in memory, and they are very fast. So I think this product was really well done, and it was taking like at least 1/3 of the world market in this area. So, okay, now talking about research. So how did we do so many fun things in research on coding for flash memories? I think one thing I learned from Shuki is that when you look at a problem, you first want to understand with the first principle method what this problem really is. So when you look at a flash memory, it's easy to think that it's just another way to store 0 and 1s. But actually, flash memories has many special properties. And I'm not going to mention all of them here, but basically one property flash memory has is that it's a special device where if you want to write data into it, you can keep adding data to it. But if you want to modify it, if you want to erase it, then you have to erase the whole thing at a time, like about a million cells at the same time. So there are properties like this that led to the topics that we worked on. And so in other words, we first need to understand what flash memory really is, how it's different from the traditional storage devices. And then we have to define a language, which is how do we represent information in such a device. And that actually made all difference on what you do later. For example, how you do error correction and so on. So that led to quite a few research topics. And that somehow relates to the thing that has been mentioned in quite a few talks early on, which is the first principle method, which is what's the right question? Because the question you ask will determine the work you do later. And coincidentally, I cited a poem by Robert Frost that Julie Pearl also used in his talk, which is there are 2 roads diverged in yellow wood, and sorry I could not take both. And I took the one less traveled by, and that has made all the difference. So the choice that you make in the beginning of your research can influence a lot the outcome that will come out. So now we have this question, when you have many possibilities, what is the how do you decide what to do? And I think one of the important research methods I learned from Shuki is that use the first principle method. In other words, when you look at the problem, we actually take away all the things that might be true, might not be true. We take away all the things that are just wishful thinking. We only keep what we know is true, the fundamental factors. And then we think of all the possibilities, and then we pick the right way to go. So we build things from ground up again, one more time. So this first principle method, I think, was also said very nicely by Richard Feynman in his 1974 Caltech commencement, which is that the first principle is that you must not fool yourself. And you are the easiest person to fool. So you have to be very careful about that. After you've not fooled yourself, it's easier not to fool other scientists. You just have to be honest and in a conventional way after that. And I believe that, I think the philosophy that Shuki believes in and Feynman believes in has a lot of common things in here. So we need to have the courage to know what is really true and what is not true, what we know and what we do not know. And we keep only what's true and what we know, then we think of all the possibilities. And once we are truly honest with ourselves, then there's nothing more to worry about. So just go ahead and enjoy your academic life. Thank you very much. So our next speaker is Li Hao.
Thank you, Andrew.
Okay, thank you.
I don't know what not to thank you for. But you are one of the students that I continued working with for a long time, till today. We always share ideas. And I'll tell you a secret.
Okay.
Many times I feel that I wish you were my advisor. It's true. Thank you.
Now we have a loop here.
Maybe when I retire, I move to Texas.
Okay.
So while Charles is working on that, let me just go back to Paradise again. So for those who don't know me, then Paul and I were actually the first two students of EE of Shuki in 1994. And when we came, we actually, our office was in trailer. And from trailer, we often saw Shuki left his office, it was in steel, at like 6:30 or 7 p.m., very late. So Shuki was working much harder than Paul and I, probably excluding Paul, but definitely me. So that's Shuki. And at one time, then probably here today, enough coding has been talked, but at one time at group meetings, we were talking about the coding and the coding and the coding. So Shuki and Mario introduced me to the the so-called array code, which is two-dimensional code. And now you have seen the power of code. And at one time, and I still believe coding probably is very powerful in many, many applications, not just the storage, not just the traditional communication now in DNA, even though I don't know anything about the DNA, but Shuki is doing work in DNA and so on. So now let me just go back to just show you one video very, very quickly, and that's the power of coding. So here I just want to show you, because I mentioned my experience, internet experience in China. So here I have two machines set up. One is in this one up one is from China. So I have two machines set up. One is in China, and another just using Ali's server. Another one is in California or in Michigan. Then one of the very popular protocol for transferring data is TCP. So many people have, basically we are still using TCP. So TCP actually, it's well known for long distance transfer, TCP's performance is really poor. So as you can see from the VPN test, so if you transfer a file from China to California, or from California to China, it takes, even though your bandwidth here is, say, 10 megabytes per second or 10 megabytes per second, you can only achieve probably several hundred kilobytes a second because of long distance and because of the sliding window protocol. So if one packet is lost because of the sliding window protocol, you have to wait until this long delay. Then you know, oh, I lost that packet. Then I retransfer. But obviously, for people sitting here, then you know one solution is just from network coding point of view. We could put coding there, right? We could additional parity codes there, and then you preemptively transfer all those parities. So here, afterwards, I really have my video here. So if you want to see, then you can see. We can increase, definitely we can increase bandwidth from several hundred kilobytes per second to several megabytes per second. Then adding, now Professor Efros is nodding, so this is part 2. Plus, if you add compression, then you can reduce this transmission time significantly by tens of times or even hundreds of times. So in one of the videos, I can show you. One using traditional SCP, it takes probably 40 minutes. Then I ask, what's your guess? of using coding and the compression and the other smart protocols together. How many minutes? It took several tens of seconds. So this is the power of coding. This is the power of coding. So hopefully in DNA research, you can apply coding type of thing and speed up the DNA computation probably by tens or hundreds of meters. So that's Eric's task, not mine, but I showed you. And Shuki will be very happy to see those kind of results. So that's just some of my nonsense.
Thank you.
Thank you, Li Hao. So you may not know that Li Hao was Shuki's first student from China. And after Li Hao graduated that year, I came, so I was the second. So thank you very much, Li Hao, for not messing it up.
Well, the part of reason was, well, you can see Shuki, so that's, let me just add another anecdote. So when you talk with Shuki, if you see he's smiling, nodding, that means you're not doing well. If he raises the eyebrow, then you know you're talking something serious. So when I was here, then most of the time, Shuki and I were talking, he was smiling. So that's why he said, okay, let me increase another sample. Here's Andrew.
Now I started to worry because Shuki is smiling at me all the time.
Yeah, the student tried to profile me. And just want to say one word. Did you mention Mr. Bean or who did?
Yeah, I mentioned.
Yeah. So when I came to Caltech, I was used to IBM where everyone is a peer and you go for lunch, you come back to a meeting area and by the evening you have a new result. Suddenly I came to Caltech and it's a completely different framework. And I said, I'm going to do a group meeting every week, no matter what. But there was nothing to discuss. So at that time, there was no digital stuff. And I just reserved a large cart with a huge TV and a VCR. And I brought Mr. Bean videos, and I told them, at least let's have fun. Maybe this mood will increase our creativity. So the group meetings were basically watching Mr. Bean. Then slowly, we started having ideas.